Picture this. It's the dark, early hours of May 29th, 1832 in Paris. Outside, it's pouring rain. Inside a dimly lit room, by just the flickering light of a single candle, there's a young man, and he is frantically writing. The clock is ticking away in the background. He's scribbling down mathematical formulas, crossing things out, writing feverishly in the margins. It's an absolute race against time. Why the insane rush? Well, because this young man knows with absolute certainty that he has only hours left to live. At dawn, he's scheduled to fight a deadly pistol duel. He knows his opponent is a much better shot. He knows he isn't coming back. And yet, instead of sleeping, instead of praying or, fleeing the city to save his own life, he's writing, row after row, formula after formula.
And honestly, perhaps the most heartbreaking part of this entire scene is his age. He was only 20 years old. Think about that for a second. It's this incredibly tragic contrast, a life so impossibly short, pitted against the sheer, monumental magnitude of the task he was undertaking alone in the dark.
Because he didn't run. He wrote. The notes this young man, whose name was Évariste Galois, was hastily scribbling down that night, they weren't just personal letters or random thoughts. They were groundbreaking mathematical proofs that would literally rewrite the future of science. So let's dive right into this explainer and uncover the story of the genius who quite literally wrote the future of mathematics in the final hours of his life.
Part 1. The Tragic Young Genius.
To really understand what happened that night, we've got to pull back and look at 19th century revolutionary Paris. Galois was born in France in 1811, right in the middle of this era of immense political conflict and scientific breakthroughs. Now, already by the age of 15, he was reading the most complex mathematical texts of his era entirely on his own. But his life, it was intensely troubled. In 1828, he failed the entrance exam to the most prestigious school in France, the École Polytechnique. Then the following year, his beloved father, who was the mayor of their town, tragically committed suicide after being targeted by a vicious political smear campaign. Just days later, a grieving Galois took the entrance exam again and failed again. In fact, historical accounts note he got so frustrated by the incompetence of his examiners that he actually threw an eraser at him. By 1830, he did manage to get into another school, but was quickly expelled for his radical Republican political rebellions. He was basically rejected by the rigid academic establishment at every single turn.
But why did the academies keep rejecting him? Well, the disconnect was massive. Traditional mathematics at the time was all about looking at separate, individual equations and, just crunching the numbers. But Galois' mind worked completely differently. Where others saw individual problems, he saw these massive, universal structures. Where everyone else searched for specific formulas, he searched for the deeper laws connecting them all. His ideas were so radical and his logical leaps were so vast that he'd often just skip writing down intermediate steps altogether. The greatest professors of his era simply couldn't comprehend his work, and they often just dismissed or even literally lost his submitted papers.
Part 2. The Unsolvable Mathematical Riddle.
So what was he actually working on that was so impossibly complicated? Well, for centuries, mathematicians had been hunting for universal formulas to solve polynomial equations. They had found formulas for quadratic equations, which you probably remember from high school algebra. They solved cubic equations and even quartic equations, which are to the 4th degree. But the quintic equation, equations to the 5th degree, where a variable is raised to the power of 5, remained this impossible mystery. Nobody could find a universal formula for it. Literally hundreds of years passed. The absolute brightest minds tried, and every single one of them failed.
And this leads us to the ultimate dilemma. The question wasn't just, how do we solve this? It was so much deeper than that. Mathematicians were starting to wonder, can a 5th-degree equation be solved by a general formula at all? Is there some invisible ceiling in mathematics that we just can't break through? Now, another mathematician had actually recently proven that a general formula for all 5th-degree equations didn't exist, but nobody knew why, and nobody knew how to tell exactly which specific equations could be solved and which couldn't.
Part 3. The Birth of Group Theory.
This is exactly where Galois steps in and just completely bypasses traditional algebra. The old way was stubbornly looking for numbers and formulas to magically balance out, right? Well, the Galois way completely stopped focusing on the numbers themselves. Instead, Galois started analyzing the symmetries between the roots or the potential answers of the equation. He figured out that it's the hidden relationship between these roots that actually matters. To easily visualize this, let's think about a physical metaphor. Imagine rotating a square. If you take a blank square and rotate it 90 degrees, it looks exactly the same as before you touched it. Rotate it 180 degrees, same thing. 270, 360, it always looks completely identical. These symmetrical operations, these specific moves you can make that leave the system looking perfectly unchanged, they actually behave according to strict mathematical rules.
And this right here brings us to the absolutely crucial point. Galois realized that if you gather these symmetrical operations together, they form a mathematical group. This is the exact birth of group theory. Galois proved that algebraic equations also have internal symmetries, just like our square. And by looking at the group of symmetries inside an equation, that specific structure will tell you with absolute certainty if a solution formula can exist or not. I mean, think about that. He solved a 350-year-old math problem by inventing a completely new branch of mathematics. He didn't just calculate, he analyzed the very structure of the math itself.
Part 4. The Night Before Death. Which brings our narrative full circle, back to that dark, desperate night of May 29, 1832. Why was he frantically writing this down right then? Because he had recently been challenged to that duel. Historical sources debate the exact reason. Some say it was a setup by political enemies, others say he was tangled up in a tragic love story. Whatever the cause, Galois knew he was totally outmatched. So in this frantic race against the clock, he wrote letters to his friend Auguste Chevalier, summarizing his groundbreaking theory of groups. And in the margins of his notes, in a truly heartbreaking testament to his desperation, he scribbled the words, "I have no time, I have no time." He practically begged his friend to publicly present his work to the greatest mathematicians of the day, just hoping someone would eventually decipher it all.
The next morning, the tragic climax arrived. Galois faced his opponent. He was fatally wounded by a gunshot to the abdomen and just left on the ground, only later to be found by a passing farmer. He was taken to a hospital where his younger brother Alfred rushed to his side. And Galois' final devastating words to him were, "Don't cry, Alfred, I need all my courage to die at 20. He passed away the following morning.
Part 5. An Enduring Global Legacy.
So what actually happened to those messy, frantic notes? Well, it took 14 years for the mathematical community to catch up to what this 20-year-old had done. When a mathematician named Joseph Liouville finally decoded and published them in 1846, it changed absolutely everything. His group theory became the bedrock for abstract algebra and the theory of symmetries, but it goes way beyond pure math. Without Galois' fields, we simply wouldn't have modern cryptography. The secure encryption that protects your bank accounts, your emails, your text messages today, it all relies on his math. Over in physics, his group theory is absolutely essential for understanding quantum mechanics, crystal structures, and solid-state physics. Computer science algorithms constantly utilize his frameworks. These massive, world-changing modern fields literally wouldn't exist without the ideas he frantically wrote down that night.
So the philosophical takeaway here is profound. Galois taught us that we shouldn't just look at the surface-level numbers. Behind every equation, behind the physical world around us, there is a hidden universe of symmetry. He saw the invisible structures governing our world when literally everyone else was just trying to do basic arithmetic. It really makes you wonder, doesn't it? Galois was ignored, rejected, and literally failed out of school because the rigid systems of his day just couldn't comprehend his genius. He lived for only 20 years, yet he altered the course of human knowledge in a single night. So what other brilliant ideas are currently being ignored today, right now, just because they are ahead of their time? If you enjoyed this explainer, be sure to subscribe to Code of the Universe. Because here, math isn't just about formulas, it's about the stories that changed the world.